All right, 11.7, this is the last section in chapter 11, and we are going to start graphing circles in the coordinate plane. So, to start graphing, if I tell you what the radius of a circle is, let's say that the radius is 4, and that the center of the circle is at 1, 2. It's a positive 1, sorry. All right, well, to graph a circle, I'm going to start at the center. So remember, this first first number is your x-coordinate, the second number is your y-coordinate, and the y-coordinate is the vertical axis, and the x-coordinate, the x-axis is the horizontal axis. So you graph 1, 2, there's my center. And from there, you're going to just go up 4, down 4, and around 4. So from the center, I'm going to count up 4. 1, 2, 3, 4. I'm going to count to the right 4, 1, 2, 3, 4. I'm going to count down 4, 1, 2, 3, 4. And I'm going to count to the left 4, 1, 2, 3, 4. So here, if I connect these 4 dots in a circular pattern, here is my lovely circle. Okay, so that's how we can graph it. Always start at the center and then go around however many times the radius is. But that's probably too easy of a question to ask you guys, because you guys are just too smart for that. So how to make it more challenging is I'm going to actually give you the equation of the circle, and I'm going to ask you to graph it. So the equation of the circle, we haven't talked about this before, but a long time ago in chapter 1, we talked about the distance formula for geometry honors. Geometry CP, I just introduced Pythagorean theorem. You can still use Pythagorean theorem to come up with the equation of a circle, but distance formula is a little bit easier. So distance formula, remember, you just subtract the x's and you subtract the y's. Well, subtract the x's, square it, and then subtract the y's, square it, and add those two and take the square root, and that's the distance of any point on a line. Or any 2 points, excuse me. So let's say I wanted to find the distance between the center point and this point right here. Well, we can count. Like, this is pretty easy. This is why I picked this line. It's from the center out to the circle is always going to be a radius of 4. So I know that the distance is 4. Okay. And then this point, this center point, we said was 1, 2. Where is this point at? Well, that point's 4 units away, so that would be 5, 2. All right, I'm going to pick this one first. And I'm going to call this my x, my y. So my x is 5, and I'm going to subtract the center point, 1, and then 2 minus this 2 squared. So is this going to work out? Well, 5 minus 1 is 4 squared. 4 squared is 16 squared. Or, I'm sorry, 16, and the square root of 16 does equal 4. So this distance formula does work out. And what we're going to do is we're going to use it to find, to generalize, because this distance formula can find any point on the circle, because we know that the radius is always going to be 4. So what I'm going to do is I'm going to leave my x and my y there, and I'm going to generalize it, because what point, regardless of where I put it on the circle, what is the second point always, always, always going to be? Well, we're starting from the center, and regardless of if I go to this point or if I go to this point, I know that these always are the radii, so these are always 4. Even though I don't maybe know what this point is, I know that this point's never going to change. It's always 1, 2. So to come up with the equation of a circle, what we do is we know what the radius is. The radius is never going to change. This first x and y could change depending on if I pick this point or this point. So I'm going to leave those as x, and I'm going to leave it as y, because those could change. But these points are always going to be the same. These are the center points, right? And rather than calling x and y, for the center we call it h and k. So this 1 would be considered our h, and this 2 would be considered our k. And so what we do is we subtract them just like we did in the distance formula. So this is how the equation of the circle is derived. It's derived from the distance formula and Pythagorean theorem, but we don't really like this radical. We can simplify that a little bit more, and to do that, we just square both sides. And what happens when you square a square root? It goes away. And so what you're left with is the equation of the circle. The equation of the circle that we're going to be using this section is pretty straightforward. It's x minus h squared plus y minus k squared equals r squared. And I want you to write that down, and I want you to write down that h and k, remember, this is our center. And I want you to write down, just in case you forget, that r stands for the radius. Okay, so that's the equation of a circle. All right, so we've written it down. Now it's time to, remember I told you guys we're going to graph given the equation because it's a little bit harder. So, for example, I could give you an equation like this. I'm going to call this problem number 2. Let's say I give you an equation like x minus 1 squared plus y minus 2 squared equals 16. Okay, well, if you look at these points, the x tells you that since negative 1 is with the x, that's going to be the x coordinate of the center. And notice in this equation, they're negatives, but the center was positive. So what you have to do for the center is switch the signs, or do the opposite. So if this is a negative 1, I'm going to call it a positive 1. And the y coordinate for the center, instead of a negative 2, well, that's going to be a positive 2. So for the center, you switch the signs to figure out what the center is. For the radius, this is r squared. So the radius is not going to be 16. For the radius, you square root whatever it is. So the radius is actually going to be 4. And now you can graph it. And oh my gosh, isn't that the same question we had at the very beginning? I tricked you guys. Sorry. Okay, so this would be the equation of this circle that we first started off with. All right, so let's try another one. Number 3. I want you guys to tell me what the center is and tell me what the radius is, and then I want you to finally graph it. And the equation of this circle is going to be x plus 3 squared plus y minus 1 squared equals 25. Okay, so pause it and see if you can do it. All right, for the center, remember, you have to switch the signs. So since 3 is with x, instead of a positive 3, it's going to be a negative 3. Since negative 1 is with y, instead of a negative 1, it's a positive 1. For the radius, all you have to do is square root it. So the square root of 25 equals 5. And now we're going to graph it. I don't know why I put graphy. Okay, so to graph it, you start at the center. So negative 3, 1. Here's my center. Then I'm going to go up 5, 1, 2, 3, 4, 5. I'm going to go over 5, 1, 2, 3, 4, 5. I'm going to go down 5, 1, 2, 3, 4, 5. And I'm going to go over 5, 3, 4, 5. And here is my beautiful circle. So if yours looks like that, you are good to go. If it doesn't, then let's try another one. If you got this one, then skip to the next section. If you didn't, then we're going to try it one more time. So this will be problem number 4. Number 4. What happens if I give you an equation like this? X squared plus y squared equals 9. Well, there's no other numbers with x and y. So to find out what the center is, if there's no other numbers, it's going to be 0, 0. The radius, remember, you just square root it, so the square root of 9 is going to be 3. So to graph this circle, you'd start at 0, 0, and then you would go up 3, over 3, down 3, and to the left 3. And here would be your circle for number 3. All right? Okay, so that's pretty straightforward. The last thing I'm going to ask you to do is to write an equation given either, given, I think I'm just going to give you guys, given, there's going to be 2 different types of this. Write an equation given what the radius is and what the center is, and then I'm going to ask you to write an equation just given 2 points. All right, so this one's a little bit harder. This one's the easiest one. Write an equation given r and the center. So let's say that the r is 6. And let's say that the center is, let's see, my favorite number is 13 and 4. All right, so remember the equation of a circle is x minus h squared plus y minus k squared equals r squared. Kind of like a squared plus b squared equals c squared, right? Okay, so for the center, remember for the center you need to switch the signs. So instead of a positive 13, this is your x, so it goes with the x. Instead of a positive 13, you make it a negative 13. And since this is your y, instead of a positive 4, it's a negative 4. And your radius, remember for your radius, instead of, it's not going to be 6, it's going to be r squared. So you need to square whatever the radius is. So instead of 6, it's going to be 6 squared, which is really 36. Okay, so that's how you write your equation given the radius in the center. So try this one. Try the radius equals 1 and the center equals negative 2, 3. Okay, and I'll check this one tomorrow. All right, the last thing I could do, and this is the hardest part, and CPA probably won't give you a question like this, but just in case you want to challenge yourself, write an equation given 2 points. So let's say I give you the points negative 2, 6, and I tell you that the center is at negative 6, 3. All right, so this time what's missing from, what's different from this question and this question? I gave you the center in both of them, but what's missing? I didn't give you what the radius is. So to figure out what the radius is for CP, if you want to graph it, or honors, same with you, if you guys want to graph this, you are more than welcome to graph it and then do Pythagorean's theorem. So how do I move this? Oh, it's kind of moving. Okay, so to graph it, what we could do is plot those 2 points. This was really not a good eraser. There we go. Fix stuff. Okay, cool. So what we're going to do is we can plot these 2 points. So negative 2, 6. Negative 2, 1, 2, 3, 4, 5, 6. There's 1 point. And then the center is at negative 6. 4, 5, 6, positive 3. 1, 2, 3. Now we can't just count. This is not, you can't count diagonally, but I can make a triangle and count horizontally and vertically and use a squared plus b squared equals c squared. If you want to do the distance formula, you're more than welcome to do it. But I can count that for this right triangle, it has a side length of 1, 2, 3. And for this side, I have 1, 2, 3, 4. So I can plug it in, 3 squared plus 4 squared equals c squared. Remember, c is just r. And you guys know what r is going to be. R is going to be 5. It's a 3, 4, 5 triangle. If you don't know how to do this, please come to tutoring because we've been doing Pythagorean theorem since September. Okay, so we know that 3, 4, 5 triangle, we have r equals 5. So the first thing you're going to do on these questions is figure out what the radius is. The second thing you're going to do, you know that the center is negative 6, 3. You know that the radius now is 5, and you're just going to plug it into the equation. So x, instead of a negative 6, you're going to change the signs to make it positive 6. For y, the y is 3. Instead of a positive 3, you're going to make it negative 3. Oops, equals. And remember the radius you need to square, so 5 squared, and that turns out to be 25. All right, so here's the equation of your circle. All right, so that's the last section, and you guys rock, and now you know how to, the equation of a circle, and you know how to graph circles.